Hey, welcome back to the IT office. In this video, we are going to talk about layer 3 switches, and we are going to do inter-VLAN routing with a layer 3 switch instead of the router and the configuration we saw in past video, which was router and stick. We're going to replace that router with a layer 3 switch. So we have this network here with 3 switches, 2 PCs, and so on and so forth, right? So we already configured a few ports. In the past video, we configured the access ports for PC1, access port for PC2, access port for PC4, and access port for PC3, each port in its corresponding VLAN, right? We also configured a trunk port here for the connection between access switch 1 and access switch 2. Now we're adding into this configuration this core switch that will be the layer 3 switch in this case, and will replace the router that we have before, right? So first we need to configure the trunk port between core switch and access switch, right? So this must be a trunk, and then we are going to configure inter-VLAN routing on the switch, on the core switch. So basically, a layer 3 switch is a switch that supports routing features. So in which scenarios do we use a core switch or a layer 3 switch? Well, in some networks, it's common to use layer 3 switch to aggregate all the connections from the access switches and do routing without getting into the router, because the routers are used commonly at the edge of the network itself when we need to have large routing tables and some advanced features like VPNs or NATs or some other features that are not required inside of the LAN. The layer 3 switch, because it is a switch itself, it has a large port density when you compare that to a router, right? So we could have multiple access switches connected to this core switch. We could have distribution switches connected to the core switch, and so on and so forth. We can connect port channels and everything. So it will be better suited for a LAN network, okay? So what's the difference with the layer 2 switch? Well, basically layer 2 switch only forwards traffic based on the MAC address or the destination MAC address of the frame, and it uses the MAC address table to do that switching, right? But the core switch, besides doing the L2 forwarding using the MAC address table, it also allows the layer 3 communication between different broadcast domains or different VLANs in this case, okay? So for example, let's start by configuring the trunk port on core switch. So we're going to do enable configure terminal. We're going to go into interface gigabit 00 switch port trunk encapsulation.1q switch port mode trunk, right? So we have configuration on this switch right now. We need also to configure the VLAN, so VLAN 10 and VLAN 20. Okay, so show interface trunk. So we have the 2 VLANs in the trunk, right? But we need to configure access switch 1 interface giga 00. Okay, so let's do that. Interface giga 00 switch port trunk encapsulation.1q switch port mode trunk, right? So at this point we haven't done anything special on the switch, and if we ping from PC, this is PC1, right, to PC3, we have connectivity. We should have connectivity. So PC3 have the IP 10.0.10.33. We have connectivity, right? And let's ping from PC2 to PC4. Let's ping 10.0.20.44. We have connectivity. And now when we try to ping from PC1 to PC2, for example, 20 to 22, we don't have connectivity yet, right? So at this point, we don't have routing between these two devices, but we have a layer 3 switch. So I told you before that the switches forward traffic based on the MAC address table, right? So for this switch, for example, we are going to have a few MAC address entries that are for the MAC address of the PC1, PC2, PC3, and PC4. So remember that since they are on different VLAN, they are like virtualizing the broadcast domain. So we have two devices on VLAN 20, and we have mapped the ports that connect to those devices. For example, if we see here, we should see gigabit 10. This entry corresponds or should correspond to PC1, and gigabit 11 should correspond to the MAC address of PC2, right? If we double check that, let's see MAC address of PC1 ends on 0800. So let's double check it just to remind you how this switching works, right? So let's see, should be this 0800. Okay, now let's check. PC2 is connected to 11, so 2900. Let's do IP address 2900. Okay, we have it here. And then we have two additional entries that we see through the connection. Let's see, is the connection to see, this is PC1, PC2. So we have two additional entries of this MAC address seen through this port, right? So guess what? Those MAC addresses are PC3 and PC4, right? But as you can see in the diagram and in this output, you have two devices on VLAN 10 and two devices on VLAN 20. What we need now is a device that performs layer 3 routing between those two networks. At this point, we don't have any layer 3 configuration on the network. We don't have a router, but we are going to use core switch as a layer 3 switch. So we start by running this command. Make sure you have this command enable IP routing, because some switches supports layer 2 and layer 3, right? But for the switch that you're going to use as a core switch, as your layer 3 switch, you need to enable those routing features, okay? You don't need to do it on the access switches because you don't want to do it routing at the access level. You want to do routing at your core level for your VLANs on different switches, okay? So now we need to create what we call an SVI or switch virtual interface. So we do interface VLAN 10, for example. It is not the same as creating a VLAN, right? This is creating an interface VLAN, which is a logical layer 3 interface associated with the VLAN 10 in this case, right? Because previously we created the VLAN, right? And the VLAN, remember, is a layer 2 concept, is to segment the broadcast domain. Now we're creating a logical layer 3 interfaces that allows routing. So we're going to run the command IP address 10.0.11 was, I think, let me double check the network. It should be 10.0.10.11. That's the IP address of PC1. So it should be 10.1, which is the IP that we are going to use as a layer 3 interface for the logical interface VLAN 1, and same for VLAN 20 IP address 10.0.21.255.255.255.0. No shut. So now we can run the following command, show IP interface brief, and you're going to see that you have now two layer 3 interfaces, one for VLAN 20 and one for VLAN 10. Okay, so these interfaces are going to be configured as the default router for each device in the network, right? So for VLAN 10 we have the default route or the gateway as 10.0.10.1, which is this interface, and for VLAN 20 we're going to have a default route or a default gateway as 10.0.20.1. Okay, let's see the magic now. If you were paying attention before, this pin to from PC1 to PC2, it wasn't working, right? So let's try now. 10.0.20.22. Okay, so what's happening in this case, right? In this case, what is going to happen first, this PC1 is going to do an ARP resolution for its default gateway, which guess what is 10.0.10.1, because it needs the entry of the default gateway before sending the pin packets, right? Why it needs to send the pin packets to the core switch or the layer 3 switch? Because devices in different broadcast domains requires a layer 3 device to send traffic across broadcast domains. So this core switch is the default gateway of PC1. PC1 sends the pin packet to the core switch, right? This is going to be sent through the trunk port with the VLAN ID 10, and then this same packet is going to be sent here with VLAN ID 20, right? And well, we strip the VLAN header before sending the traffic to PC2, right? Same process in the other direction. So PC2 needs to return the packet. It needs an ARP for its default gateway, which in this case is 10.0.20.1. It will send that packet to the core switch, and the core switch will send it to PC1, right? So don't mix the two concepts, right? So layer 2 VLANs segment the network into broadcast domains, but you need a layer 3 interface or an SVI to send traffic from one subnet to another subnet, okay? So keep that in mind. There are some different switches that have different syntaxes for these commands, but basically it's the same. So when this switch is a layer 3 switch, it will have a routing table, right? So it will have two routes or two connected networks, which is the 10.0.10.0 and the 10.0.20.0. That's how the core switch or layer 3 switch knows how to forward the traffic from one network to the other. So let's do the same exercise and let's make a packet capture here. Let me show you the flow. Okay, so let's filter by ICMP. So we are capturing on the trunk port, right? So let's do a ping from PC1 to PC2. Okay, so that's enough. Let me show you what is going on here. So let me this column here, ID column, corresponds to the VLAN ID, right? So let's see. Packets, source of the packet is 10.0.10.11. Destination is 10.0.20.22. This is PC1, this is PC2. Okay, so this pin request is sent by PC1 to this access port, and then access switch 1 is going to add the tag 10 to the ICMP packet, right? So that's why you see here the VLAN ID 10, and if you check in the frame header, you see the 802.1q with the VLAN ID 10, right? Then that same packet, that same request is sent, well, the IP address, source and destination, they will not change, But now the core switch is sending that packet here, right? Because the network is connected to its logical interface in the VLAN 20. And then it's adding the VLAN tag here, 20, to the ICMP packet, right? So we have the ICMP packet with the VLAN 20 in the header, and that's the same request, and that request will eventually reach PC2, right? So in the let's see, in the other direction, we'll have a response, right? So this response comes from PC2 to PC1, right? If you see the reply, now, since this packet is sent from PC2, when it passes across this strong connection, the access switch 1 will add the VLAN ID header to the frame, right? And core switch is going to route that packet back, right, to VLAN 10, and will add the VLAN ID 10 to that frame, right, like this. And then, well, by the switching forwarding, it will be sent from access switch 1 to PC1, right? So we do routing here, and we do L2 forwarding here, right? Also, that doesn't mean that a PC core switch doesn't have a MAC address table. It will have a MAC address table because it is also a switch. Okay, so it will have some entries for the devices in VLAN 10 and VLAN 20. So in that way, it knows where to forward the traffic after it does the routing, right? Also, it will have, you will see here, the routing table, the MAC address table with the entries, and you will have an ARP table, right? For the devices in the network. Remember, any layer 3 device that needs to forward traffic, it requires the ARP entry of the target device. So for example, PC1 requires the ARP entry for the default gateway to send the packets out of this network, and PC2 the same, and it needs an ARP entry for its default gateway, and core switch also will require the ARP entry for PC1 and PC2, right? So the process is like this. First we do the switching, we do the forwarding, then we do the routing, right? And we need, in every layer, we need to complete the headers, right? It will be the IP addresses or the MAC addresses. And remember, the ARP protocol is the protocol that helps us do the resolution for the MAC address associated with the corresponding IP address. So in summary, core switch or layer 3 switch does layer 3 routing, right? It's used in LAN networks. It doesn't have the same features as the routers, but it has more port density. It has more port density. It has some extra features to do, for example, virtual LAGs or MLAGs or VPC, as Cisco call it. These devices can do stacking. They have different connectivity technologies. So for high port density and fast switching, we can use a layer 3 switch instead of a router. Okay, so that's it for this lab. I hope you have enjoyed this video. Don't forget to leave the comments, turn on the bell, and well, we'll see you in the next video.